Hi and welcome to challenge number 16, remove duplicates. In this challenge, our task is very simple. We are going to have this as an input. This is an array of numbers in which, if you take a look at, we have two items that are similar here, and then we have two items that have been repeated here. Our task is to convert this array into this one by removing all the duplicate elements. So we need to take a look at every element individually and then get rid of the that element's repetition if that element has been repeated. All right, and the same goes for the strings array. So we have two inputs, one numbers array, one strings array, and then we are going to have the same inputs, one numbers array and one strings array, but the input and the output are the same data structure. Both of them are arrays. The first language that we're going to get started with is JavaScript. So let's go ahead and let's get started. Now, the first solution that I'm going to go about for this language is going to be using the set method. We're going to talk about three different ways of removing duplicates from an array, but the most concise and the most modern way is to use a set method. A set is a data structure that removes duplicates automatically. So within a set, you cannot have duplicate elements. And we could just leverage that. So here, I could just call it remove duplicates 1. This function accepts an array, and it should return an array as well. But since the notation of set is different than an array, what we need to do is we need to just convert that into an array. But first off, how do we create a set? We are going to say new set constructor, and we're going to pass in our array here. And what this produces for us is a set with curly braces. Let's take a look at that. Let me just cut that, paste it right there, save it. And here we're going to call our function remove duplicates. Let's save that. And let me just get rid of this terminal, create a new one, cd 16. Let me take a look at this. So O16, right? O16 tab enter, and then note A tab enter. So you can see, what do we have here? We have a pair of curly braces. That's the notation for a set. It's right here. But since we want to return an array, this is not a notation for an array. We need to convert this into an array. Now, I didn't pass anything to this function. What we can do is we can just pass in our input from here, just to here. Let's save this. And now you are going to see how this actually works. There we go. So we got our solution right here. See, we have our solution. We have 1, 2, 3, 4, because set automatically gets rid of duplicates. But now the other problem that we have is we have this curly brace, and then we have the actual set that shows how many items there are. So how do we get rid of it? Now, what we can do is we can spread all the items that set has, and effectively we get rid of the the curly braces of the set, as well as the set keyword itself. So now let's save it. Let's take a look at it. We get 1, 2, 3, 4. All right, that's good. Now, we need to return an array as well. So I'm going to surround this by square brackets, which means this is an array. So if I run this again, there we go. We got 1, 2, 3, 4. And that's exactly our solution. So from here, I'm just going to say, okay, return this. And now you know how this works. I'm going to get rid of this as well. We're going to just copy paste all of the console logs. I just wanted to show you set because I feel like it's the kind of data structure that has been underutilized. So that's why I just went into a little bit more detail. But I'm going to try to keep your level in mind and not explain everything to the finest detail. Because at this point, if you have been, especially if you have been following along, this is our 16th challenge, and we have done challenges that were way more complicated than this one. So let's move on. Let's talk about the second one. The second and third solution definitely are more complicated than the first one. But since you're familiar with the flow of the method, it's going to be easier for you to understand. The only part that might be challenging is going to be the flow of the logic, how logic flows. So in this one, what I'm going to do is I'm going to use the filter method along with the index of method. And I'm going to explain why I'm going about this way. So we have our function remove duplicates. We are going to just name it 2. This is going to accept an array. We know what that is. Now, we are going to return an array as well, but let's just get started with filtering. So whenever we use a filter method, this is going to create a new array, and it is going to only add items to that new array if they pass a test. What is that test? Let's take a look at it. So we have a specific element. I'm going to write for any loop iteration. Now these array methods, they're all underneath the hood. They have this for loop. They iterate over the actual array, and in each iteration they select one element. All right. So the element that they select is element, and the index of that element is index. Just so everything is clear. I'm not going to open up curly braces. I'm just going to do parentheses. Or maybe I don't need even that. So let's just hit enter. I'm going to go back just to make sure that everything is readable enough. So what is our test? We are going to leverage the index of method. The index of method gives us the index of the element in its first occurrence. So let's take a look at our input array. It's right here. Let me just put it right here and comment. So if I take a look at 1, does 1 have any other occurrence? No, it doesn't. Okay, let's move on. Let's take a look at 2. Is 2 being repeated again? Yes, right here. So what index of does is it's going to store the index of the first occurrence of 2. What is the index of this number 2? It's 1, right? Since this is a numbers array and indexes are also numbers, it might be like a little bit confusing. So let's take a look at the strings array. That's easier, right? Comment this one out and here. So we have A repeated once, occurred here, and then repeated here, and then again repeated here. So the first occurrence has an index of 0. The second occurrence has an index of 1. The third one has an index of 0, 1, 2, 3, 4, right? So the third one has an index of 4. Index of is just going to store the first index of the first occurrence. And in that way, we can filter out the repetitions. All right, so how do we go about this? We're going to grab our array and we're going to say index of that element. So if the index of the element is equal to the current index, that means it's a unique element and we want to keep it. Otherwise, we're not going to keep it. What do I mean by this? So let's take a look at it. It's very simple. We're just going to talk about A. I feel like I need to zoom this in a little bit. There we go. So we have this A right here. What is the index of this? It's 0. All right. So here we're going to write 0, right? I shouldn't write it there. Let me just go back. So the index of that is 0, and we have triple equality, and then we have the other index. So the index of this is 0, but what is the index of that loop's repetition? That is 0 as well, right? Because this is the very first loop iteration. So both of them are equal. This means this element, this item A, has passed our test, and we put it inside of the array, the newly created one. All right, very good. Now index of knows that the index of A is 1. It's 0. Index of knows that it is 0. If we go to our second iteration, what is the index of this A? Well, it is 1. There we go. So this index is 1. But index of remembers, okay, the index of A was 0. Is 0 equal to 1? No. So this A does not pass these tests. Therefore, we're not going to put it inside of the array, the newly created array. All right. So effectively, what we did was we got rid of the repetition of that. So now in the next iteration, we have B. Now B is a different element, right? An index of just stores the index of B now. So it's 0, 1, and 2. And when B is repeated again at the end, it knows that 2 is not equal to the index of the last element. And in this way, we actually end up with an array that has only unique elements. Let's go to solution 3. For this one, we're going to use the reduce method. The reduce method along with the includes. So includes, there we go, very good. So we have our function, remove duplicates 3, we pass in our array. We're going to test all of our solutions at the end. So we have our array.reduce. This is a very, very beneficial method for you to master, especially in front-end web development. This is all over the place. So you need to really understand what happens here. So array.reduce, it processes array elements one by one, and it builds a final result. The first parameter of this array.reduce is always a callback function. So this thing, the first parameter is a callback function. And then I'm going to add our function block. And then, where is my function block? There we go. And then I'm going to add a comma. That's the second parameter or argument that this function accepts. That's an empty array. And this is going to be the starting point for our accumulator. So an array.reduce basically gets something very big, and it, based on some logic, it reduces it to something smaller. It is the same thing, but it changes or it reduces that in size, in quantity, in quality. All right, it just reduces. That's why it's called reduce. It reduces that. All right, so we have an array that's too big, like this one. It has 6 items. It reduces that to 4 items. We have an array here that has 7 items. It reduces it to 3 items. That's the array.reduce. So for an array.reduce, the first parameter should be function, callback. The second one is going to be the starting point for the reduction. The starting point of the reduction is an empty array because we want our reduction to end up in an array as well. So what kind of parameters do we pass in? Now, the first parameter that you pass in, the value of that is this second argument right here. So the first parameter that you pass into the callback function inside of the reduce has a value equal to the second argument of that reduce method. I hope it's not confusing. It's very simple. So here I pass in unique. Unique is what? Unique is something that we call an accumulator. It accumulates, it adds up, it takes everything, all right? You can think of it like it eats everything, all right? So this is our accumulator. What is the initial value of this unique? It's this array. Again, the first parameter within our callback function has a value equal to the second argument that we pass into reduce. So, and then we need to have something that takes a look at every array element individually. And that is our loop agent, as I would like to call it. And that's the element. All right. Now, what do we do here within this block? How do we go about this? Well, we take a look at that. If an element exists inside of our accumulator array or a unique array, then and then we want to re-add it, then that means it's a duplicate. We get rid of it. But if it doesn't have any occurrence inside of our unique array, then that's the first occurrence and we just add it. How do we go about this? Well, we can take a look at our includes method. So here I'm going to say, if my unique array, now keep in mind, I'm not targeting the array that the function accepted. I'm targeting the unique array. If unique array includes this element, if unique array includes this, so this is going to be our test. If this is true, then what we want to do is we just want to return our unique element. Because since the element is already in there, we don't want to make any changes to our unique array. We just want to return it. But what if the element doesn't exist? So in the case of our strings, we have A A, B, C. So in the first iteration, when we take a look at the first A, does the first A exist inside of the unique? No, because we know unique array is empty. Right here, it's empty. There is nothing. So when there is nothing, how do we add it in there? Well, we open up our array and we can spread all the previous elements. Now this is, again, one way that we go about this with use state inside of React applications. You never want to overwrite the previous state of a data structure. You want to keep the previous state as it is and add on to that previous state. In the first iteration, doing these 3 dots unique doesn't make sense because we didn't have anything before it. But what if in the second iteration, third iteration, we don't want to, in every time reduce iterates over our array, we do not want to get rid of all the previous elements. So we want to keep the previous elements and add on to it. So we keep all the unique elements by using the spread operator, and we add on to it a new element. If you don't do this, in each iteration, if you add an element to the unique array, you will effectively end up with an array with just one item, because that item has replaced all the other items before it. You will never end up with an array that has more than one item. All right? I need to emphasize this. You need to spread this so you have all the previous elements, and then you add on a new element to the previous elements. All right, so let's take a look at it. In the first iteration, we get A. Since A doesn't exist inside of unique, we add it. All right. In the second iteration, A exists inside of the unique, so we just return that array. All right. Let's go to the third iteration, B. Does B exist inside of unique at this point? No, it doesn't. So we want to put B inside of this unique array. But do we put it right next to A using the spread operator, or do we overwrite A with B? Which one? Well, we put it next to A. We don't want to change the array by getting rid of all the previous items and add a new item. We want to keep the previous items and add another item to it. And this is how you keep the previous items. It's very common in React apps. So that's why especially if you're watching JavaScript, you're interested, it's React most of the time. So this is like a very good thing that you need to understand, especially when you're updating use state. That's something that I just wanted to talk about. So here, and I believe that is it here for us. So we're done. What I'm going to do is I'm going to get rid of these. I have our print statements right here. We have our test array number, and then we have test array string. This is our array of numbers, and this is the string one. We have all 3 cases, original, and then we have the string. Let's just save this. Let's go to terminal, clear everything. And now if I run this, I need to move this up. There we go. So we have one, I should show it like this. So this is our array with these duplicates. And then after that, we got this 1, 2, 3, 4 with the set, 1, 2, 3, 4 with the filter, and 1, 2, 3, 4 with the reduce. So, and moving on, here we have our strings array. With the set, we get ABC. With the filter, we get ABC. With the reduce, we get ABC. Now, since at this point in time, I do not want to talk about the performance of these challenges, aka algorithms. We're not going to talk about them. For now, I just want to practice programming with you together. And then once we have reached a certain level of confidence with code that I don't have to explain, like I feel like I needed to explain all of these. Once I have that connection that I don't have to explain everything to the finest details, then we are going to perhaps introduce some theoretical concepts when it comes to understanding the performance of a challenge that you solve. These methods, all of them, they affect the speed of your application in one way or another. But for now, I just don't want to talk about it because this is way more fun than that. And we would just want to practice our programming for now. So we are going to get to those in good time, in due time. So let's move on and let's talk about the second language in which we want to solve it. And if you have been following along, you know that this is where I actually test the strength of a language manually. How much can I move forward by just using, by not using any built-in method, by just going old school with these challenges. And let's get started by defining our function. This is going to be remove duplicates. And since I want this function to either accept an array of numbers or accept an array of strings, we could leverage the generic functionality of TypeScript. So we're going to have one type at any specific moment. So this array could have a type of number. The items within the array, the input array, could have a type of number, or they could have type of string. And that is going to be what's going to replace this type t. And what do we return from this function? We return whatever type t was. So if t is type number, the function is going to handle a number. This is going to be a number. And the input array is going to be a numbers array. And what the function produces will also be the same thing. So now let's go ahead and let's try to come up with the solution for this. So let's just think about what we need. We need an array that is going to include all of the items that are not duplicates. All right, so let's just create that and then move forward. So I have this array. I'm going to call it, you could call it whatever you want. I'm going to call it unique array. And this is going to have, what is going to be the type of this? Well, it depends. It could have a type of number or it could have a type of string. But since our function is generic, we don't have to specify that. We're going to say, okay, the type of this is type t. So if t is number, it's going to be number throughout the life cycle of this function. It's going to be number. But if it is a string, it's going to be string all from the beginning of the function until the end of the function. All right. So I'm creating a new array right here that's called unique array, and it's going to hold all the items that are not duplicates. Now here I need something else as well, and that is I need a counter, and I want to use that counter in order to place elements at their correct position, because in the process of removing the elements, I don't want to disturb the order of the elements that I had inside of my array. So I need to know where I'm putting these elements. So that's one reason. And the second reason is that I don't want one element to occupy the place of another one. So I need to keep track of, I need to have a state variable to keep track of which spots have been occupied, which spots have been already occupied, and which spots are free, right? And I'm going to call that, let's just grab it, and we could call it unique count. And we're going to get started with 0. The reason that we start with 0 is because arrays, the indices for arrays, they start from 0. So we want this unique count to specify the location or the place for any individual item. And that's basically the index of that item. That's why I'm just going to call it unique count, and we are going to get started from 0. So now we need to have some sort of a loop to iterate over our input array. All right. So you know what? I could just call this input array just to make sure that it is understandable. So here I'm going to say for let I, this is going to be our loop agent. It's going to start from 0. Because indices start from 0, that's why this is going to start from 0. But since indices start from 0 and the length of the array, which is going to determine how many times this loop is going to run, that length starts from 1. Index is going to be 1 less than the length, because index starts from 0, length starts from 1. Therefore, we're going to say this I is going to iterate for as long as 1 less than the length of the input array. All right. So if you start I with 1, then instead of this angle bracket, this lower than sign, you could just use an equality sign. But since this is a convention, I'm just going to go with that. Both ways work. And then once one iteration is completed, we need to go to next iteration in order to cover the entire elements of that array. So what do we do here? Well, we need to first store that specific item of the array. All right. Now what I need to do is I need to copy both of these, put it right here so I can just show it to you. So in the first iteration, we talk about 1, right? For this numbers array. Or let's just talk about the string, that's easier. So I is 0, and the item that I selects from the array is A. Okay, let me store A somewhere. I need to have it somewhere so I can use it. I'm going to say const, I could call it current element. Again, you could call it whatever you want. And what is my current element? Well, in the first iteration, the current element is A. In the second iteration, it is still A. In the third iteration, it's B. So in every iteration, this element is different. So is it okay for me to just write A and then go ahead and write A and then go ahead and write B, or just get it systematically? And let's just get it systematically. That's easier, right? So I'm going to grab my input array and I'm going to pass in this I in there. So when I is 0, it's like this. So I is 0. Let me pass in 0 there. What does this expression tell you? This one. This tells you in the context of arrays that give me the item located at the index of 0. And which item is that? That's this A. And then this is the first iteration. We increment the iteration by 1. So this goes to 1. And what does this expression tell you? It tells you, give me the item at the index of 1. Right? The previous one was index of 0. This is index of 1. And we get this item. So in every iteration, we proceed with this through, we basically travel throughout this array until we get to the end, until there are no more elements. So length of this array is 7. So we are going to iterate 6 times, right? Using this logic, this is our condition, 6 times. But if you count in 0, 0, 1, 2, 3, 4, 5, 6, that's exactly 7 times because we have 7 elements. So this is how this for loop actually works. Very simple. Now that we have our current element in that specific iteration count, let's actually try to understand if this element already exists inside of our unique array. Now, for this one, we need to have another state variable as well. As I said, we want to make sure that this is as manual as possible. So we had one state variable, unique count. The job of that was to place elements at the correct position. The job of unique count, this variable, is not to take a look at duplicates. If there is any other element like this one already inside of the array. This has only one job, and that is put element in the right position, in the correct spot. So we need to have another state variable that is going to decide if this element has already been duplicated. So we're going to call it is duplicate. And initially, in the first iteration of this loop, is the element duplicate? No, it's not, because that's the initial one. This A is the initial element and there is no element before it. So initially, the value of this is going to be set to false. This is a Boolean value. So is element duplicate? False. That means no, it's a unique element. Is element duplicate? True. That means yes. We already have an A element inside of our array. All right. Now that we have these two state variables to keep track of the place or the spot, as well as the uniqueness of that element, let's iterate over our unique array as well. Because what this just does is it's just one variable with an initial value of false. Well, what happens in the next iteration and in the next iteration and in the next one? So we need to take a look at what's inside of this array. Now keep in mind, at any point in time when we're working with this function, we're working with two different arrays. So that's why we need two different for loops. Why do I say two different arrays? So the first array that we're working with is our input array. But then the second array that we're trying to populate, aka working with, that is our unique array. So throughout the function, we work with both of these arrays. So we want to take a look at if any element from the input array already exists inside of the unique array, because after the first iteration, unique array is no longer empty. It has something inside of it. So shouldn't we iterate over this unique array to find out what is inside of it so we don't repeat ourselves? So at this, with this current methodology that we have here, it does not check for duplicates. Nothing checks it. So with this current methodology, what we do is we copy all the items from this input array and we directly paste it inside of the unique array. And that's not what this challenge is about. We need to copy only the unique elements and put it inside of this unique array. Only the unique. So in order to do that, we need to take a look at what's inside of this as well after the first iteration. So that's why inside of this for loop, we are going to have another for loop that is going to check the content of the unique array. And I want to repeat this. In the first iteration, unique array doesn't have anything, but after the first iteration, unique array has one item inside of it. The first item of the unique array is always the first element of the input array. Okay, so inside of this numbers array, the first element is 1. Inside of the strings array, the first element is A. The first element will always be copied inside of, it will always be copied to the unique array. But if the next elements follow that process, that's the job of this inner for loop that we have. Do the next elements have to be copied as well or not? Let's take a look at that. So the convention is that the inner loop is going to be j. We're going to get started with 0. But then again, we take a look at how many items are inside of our unique array. But a better way to actually check this is using our unique count, because our unique count is the variable that keeps track of the positions or spots that have been taken. So let's just say j is less than our unique array, unique count. And let's go ahead and let's increment j plus plus as well for our next iteration as well. Now, how do we make this check? Well, we check if any item within our unique array is equal to our current element. If it is equal to that, then that is a duplicate. So we want to break out of this loop and don't add it to our unique array. All right? So how do you do that? Let me just move forward. So if inside of my unique array, there is an item that is equal to the current element in value and in type, then that means it is a duplicate item. And this basically means that this inner loop has done its job and I can break out of it. It's a better convention to break out of your loop if you don't want to do anything else. You don't want to go to the next iteration, just break out of it. Now, what did I do here? So in the first iteration, our first item is A. That means current element is equal to A. All right. Is duplicate is false. Cool. We iterate over our unique count. We see that our unique count is 0. Now 0 is not less than 0. So we don't even go inside of this loop. We don't go inside of this loop, right? Now, we need to have some sort of a logic to copy this element, this A item, to put and copy it and put it inside of the unique. We're going to write that. But in the second iteration, again, we have A. So our current element is A. Now, once we have this logic that puts the element inside of this unique array, unique count is going to be incremented by 1. So now unique count is actually 1. It's not 0. And 0 is, yes, less than 1. So there is going to be one iteration for this loop. All right. So we say unique array, the item within the unique array at position 0 is A, right? That's what we have added. And our current element is also A. So this condition holds true, all right? So we jump inside of the if statement. Inside of the if statement, we say this is a duplicate because A is equal to A. That means it's a duplicate element. We break out of this loop. Now keep in mind, this flag has become true. Now, how does that help us? we say that as long as this is duplicate is not equal to true, we want to add items to our unique array. Where do we put the item? We put it wherever unique count tells us. And what is the item that we put? It is going to be our current element. And then we select our unique count, we increment it by 1. Now, why do we increment this by 1? Because unique count, remember, it is the index. It specifies the spot where an element goes. All right. So I've put one item at the position 0 inside of this unique array. So position 0 has been taken. What is the next position? Plus plus, which is 1. So once one position has been occupied, we go to the next position. And that is just one incrementation. That's 1 plus 1. And then when position 1 has been occupied, we go to position 2. All right. So unique count, as I said, is 1 here. And then we go inside of this loop. We turn on the flag to true for the second A. Right? So second A is a duplicate. Now that makes us not go inside of this if statement because now is duplicate is true. This condition does not hold true. Therefore, we do not add the second A inside of our unique array. And that's it. That's very simple, right? So this is basically the entire challenge if you want to do it manually. And finally, what we return from this function, it has to be an array, right? And there we go. And I already have written our print statements. I'm just going to copy paste them here. They're very structured. So here we have our numbers array right here. And then we pass it to this element, to this function, remove duplicates, numbers test, input and output. And the same thing goes for our strings as well. And now let's actually take a look at this inside of the terminal. So I'm going to say TSC B merge two arrays. Whoops, that's the previous challenge, sorry. So I should say TSC B hyphen tab, let's hit enter. And then we need to say B, remove duplicates. Now keep in mind, once you do the node command, you need to make sure that it is B hyphen remove duplicates.js. Let's hit enter and there we go. So what do we have here? Here we have our input array. This is the output, 1, 2, 3, 4. We don't have any duplicates. We had 2 2s and 2 3s. And here we have only, for this input array, we just have this output, A, B, and C. And that's it. So with this, the TypeScript solution has come to an end. Let's jump in and solve this with Python, which is our third language. For the Python solution, we're going to go with 3 different methods. So we're going to have 3 different solutions to this challenge, much like the JavaScript one. So let's go ahead and let's take a look at each one of them individually. We're going to have remove duplicates _1. This is our very first function. This accepts an array. And in the first solution, what I want to do is I want to use a method that I believe I've not used so far for our Python challenges. And the method is called from keys. So what it basically does is it's going to create a dictionary with the array elements as keys. A dictionary in Python is like an object in JavaScript. So an object or a dictionary has key value pairs. We are interested in the keys in this specific scenario. And this from keys is going to create a dictionary for us. And the array items are going to be the dictionary keys. All right. And I'm going to tell you why I'm doing this. So let's go ahead and let's, now this from keys is available on the actual dict or the object. All right. And in here, I'm going to pass in our array. Now, what this gives us again is array items as dictionary keys. Why am I doing this? The reason that I'm doing this is because this specific method, when it creates dictionary keys, it gets rid of all the duplicate dictionary keys. So for our strings array where we have 3 A's, it's just going to create 1 key for all 3 of them because 1 is unique. The other 2, they're just duplicates. So it gets rid of all the duplicates on its own. But now what this gives us is a dictionary. We want to convert it into an array or a list. So let's go ahead and let's surround this by a list method. And that's exactly what we are going to return from this function as well. And that's it. So this is solution one. Solution one. And this is dict from keys. Come on. And that's it. All right, let's talk about the second solution. Well, using for the second solution, we're going to use a list comprehension, which is you can call the most Pythonic way of going about this. So this is going to be list comprehension. Very good. So we have our function remove underscore duplicates underscore 2. We're going to pass in an array, and let's see how we go about this. Well, I'm going to create a set to track which elements we have already selected as unique elements. So I'm going to say unique. I'm just going to call it unique, and this is going to be a set for us. Now, where is our list comprehension? Well, the first thing that you do for a list comprehension is you open up the syntax, which is the square brackets. So we have this element, this item X, and we are going to use this to iterate over our input array. So we're going to say X for X inside of our array. All right, so now we have this X, it goes inside of the array. It does what? Well, it does something, but it does it based on a condition. Well, what it does is simpler than the condition. So let's just write what it does. I'm just going to go to the end, and in here, I'm going to write what it does. So what it does is it selects our unique set, and it adds onto it this value, this item, which is X. Now, it has to do this based on some condition, because we don't want just copy all the elements from our array inside of our unique array and not remove any duplicates. We want to remove duplicates. So for removing duplicates, we need to have some sort of a condition. And the condition goes like this. So if this X or this specific element is not inside of our unique set, we want to add it there. But I want to add this part to our condition as well. So you can see here we have, let me just show it to you. So here we have this unique set, and we say, okay, I want to add this X to this unique if it is not already in there. But then where do I actually say I want to add it? I say if this is not inside of unique. So what I need to do is I need to bring back this part into the if statement as well. So the cool thing about this is that whenever we say, okay, this is unique.add, we call this add method on a specific set, and we add an element to that set. This add method, it returns a none. So a none like this. So it returns none. It's like the null or undefined. It's like the null in JavaScript. So it returns a none. So if we say it is not none, then that's going to be true for us. So what we want to do basically inside of this if statement is that we have two different sides to the if statement. The first side says that this specific element has not already been added. The second side says that if the first side is correct, then I'm going to add it. So for this if statement to actually work, both sides of the logical operator has to be basically evaluated to true in the Boolean terms. So what do we need to add here? We're going to add the AND logical operator. So with the AND logical operator, we have the left-hand side has to be true as well as the right-hand side. So the left-hand side actually makes sense if X is not already inside of our unique set. But the right-hand side, it returns none. All right, but none is actually a falsy value. So how do you convert a falsy value to a truthy value? We just pass a not. And there we go. That's it for the solution. The only thing else is that we need to return it. So now just to recap, none returns true. And if x is not inside of unique, that returns true as well. So this entire condition evaluates to true, and then we add it using this. Using this, we add it to our set. And in this scenario, in this way, we move on with all the elements that are not duplicates. Let's go ahead and let's create the other function, remove duplicates _3. We're going to pass array. So what do we want to do here? Well, in this one, we're going to use the for loop syntax of Python in order to populate an array with all the unique elements. You could call this unique array or unique or result or whatever. I'm just going to call it unique array, and I'm going to initialize it with an empty list. So whenever we iterate over a list in Python, we have access to the index and to that specific element at that specific iteration count. Now, instead of just saying that I want to iterate over the array, I'm going to say I want to convert the array, or basically enumerate the array and then iterate over it. So I'm going to say enumerate, and then let's pass in the array, and I'm going to tell you what this enumerate actually is. So enumerate, what it does is it converts, it basically loops through the array, and for each element of the array, it creates a pair. The pair has two things inside of it. So for our strings array, the first element is what? It is A. So it's going to pass in A. But what is the index of this element? The index of this is 0. So enumerate creates a pair like this. It adds the index as well as the actual element itself inside a pair of parentheses. And then it adds a comma. It does it for the next element. So for the second element inside of our strings array, that's an A as well. But the index of that is 1. So it passes that here. And then for the third element, let's do the third one. The index is 2, but the element is B. So we could just take a look at it here. There we go. And then we have C, A, C, B. And it goes on like this. So we have C, let's just do C and that's it. The index is 3, but the actual element is C. And in this way, it enumerates that specific array. Now, since we have this pair, we have a pair that is consisting of the index as well as the item itself, we can take a look at if we have any duplicates. So I should have basically written that here. We're going to use this third solution. It's going to be using the enumerate method plus for loop, right? So what do we do here? Now that our array is basically a pair, like a bunch of parentheses, inside parentheses we have the elements as well as their indices, let's take a look at how we can select an element that has not already been selected. So in the very first iteration, right, we have this element that's called A, the index of which is 0. We're going to take that as our example. We're going to say if the array's items index, whatever that index is, for that specific iteration count of that for loop. So in the first iteration, element is A. So when we say array.index A, that's going to give us the index of A. What is that? It's 0 because it's the first iteration. All right, cool. Now, we say if this is equal to the index that we have gotten from this iteration count, which you know what, I'm just going to write index and I'm going to convert this to index so it is really understandable. So if the index of the element that we get from the array is equal to the current iteration count's index inside of our for loop, then that means it's the first time that this item has been seen. So what do? Well, we select our unique array and we append that specific element to it. Now, so far, the only thing that we need to do here is we're going to get rid of we're going to get out of our if statement with just one backspace, and another backspace gets us out of the for loop, but still inside of the function. And then here we're going to say, okay, let's return the unique array. Now let's go to the second iteration and see how this works. So in the second iteration, the element is the same, but there's just the index is different. But now keep in mind, this index method that we have invoked on this array, it works like the index of method that we did in JavaScript. It memorizes the first index. It memorizes basically the index of the first occurrence of this item. So if we were to have 1,000 different A's, the first index of the first occurrence of this element will be inside of this index. Even though in the second iteration we still have A, index remembers, okay, the first index of this element was 0. So it's just going to retain that. So this is going to be 0, all right? This index is going to return 0. But in which iteration count are we? Well, we did the first one, now we're in the second one. So in the second iteration count, this index is no longer equal to 0, right? It's 1. Because we started from 0, we go to 1. But this returns 0. Is 0 equal to 1? No. So we don't add it. That means it was a duplicate. We don't add it. The same thing that we did in JavaScript. Right? So with this, the challenge for the solution for all three has come to an end. Let's go ahead and let's actually print these. We have our test and I've already done all of that, so you don't have to worry about it. Let's say cd this, clear this out, Python, C tab enter. There we go. So what do we get? We have this 1, 2, 2, 3, 3, 4. These are the solutions that we get, solution 1, 2, 3. And for our string, we still have solution 1, 2, and 3. The same thing. Very, very cool, right? So with this, the solution for Python has come to an end. Let's go ahead and let's talk about the solution in Go. Whoops, we wanted to collapse the sidebar and I pasted our code. So in here, well, since we are inside of Go, what we need to do is we need to introduce our main package. Now, we need to have a function to do this removing of duplications or remove duplicates. Now, I'm just going to have one solution, one type of solution for Go. I'm not going to have more than that. I wanted to come up with more solution types, but then I ended up with sort of repetitive code. So I didn't like that. I just said, okay, this one is enough. So what we are going to do is we're going to use some newer features of Go in order to solve this. We're going to use generics in Go. All right. So first off, what this function is going to accept. This is going to accept an array. The array has a type of T, exactly like TypeScript, but just the place of the notation and the letter, they're basically reversed. So it has a type of T. What does the function return? Well, the function returns the same thing. If you pass in an array of numbers, the function produces an array of numbers. If you pass in an array of strings, the function produces an array of strings. So far, everything is clear, right? Well, I need to get rid of this colon. Now, let's truly understand what is going on here because we have not had generics in Go up until now. So let's see. We have this T. This is actually something that's called in statically typed languages. This T is a convention. And it is called a type parameter. This is just like a variable, but for types. The reason that we write this is, again, this is a convention. You could write K, you could write A, or you could write B, C, but the convention, what a lot of developers do is for a type parameter, since it signifies a type, T, that's why we write T. Why do we write T? Why don't we just specify number or string? Because in Go, you need to specify what the type of array is. Now, we want to have this function to handle both an array that has all numbers and an array that has all strings. Now, if I specify that this t is a number, then this function can only handle numbers. And the same goes for strings. So I want this to be generic. A generic function is the opposite of a specific function. A specific function accepts a very specific thing with a very specific type, and it produces a specific thing with a specific type. But a generic one, it has a broader range of what it accepts as arguments as well as what it produces. So that's why it says generic answer, all right? Like you see a generic answer online or whatever, like a generic response. This is a generic function. It's not specific. It's a general thing that can handle everything. That's why we say T. Instead of two functions, we can just have one that can handle strings as well as numbers. Now, in Go, this is a relatively newer feature. And in order to actually use this T, you need to have something that's called a comparable. So what we did in TypeScript was we had angle brackets right after the name of the function to signify that this function is a generic, right? Now you need to do that in order to signify that this is a generic function. It is generic function is very flexible, right? It's not fixed. So here we say that this T is actually a comparable. And this is how we create a generic function in Go. Comparable is basically a constraint in Go. This basically means that whenever I write comparable, whenever I write comparable next to T, comparable makes this T support equality sign, not equality sign. All of this also includes that this comparable makes this T support an integer type, a string type, a float 64, a boolean, array, structs, whatever. So this is very important to make this T flexible. All right? Now, if I call this function, if I call this remove duplicates function, and I pass in the type of T as integer, this T right here. That means the array is only going to accept an array of integers, and the array is going to, this function is going to produce an array of integers as well. Now, we did say generic is not specific, but once you specify it, since you can see it's T, T, T. If the first T is integer, the second T and the third T, it doesn't matter if there are like 100 T's inside of this function, all of them are going to be integers. So once you specify it, it's no longer a generic function, it's a specific one, all right? But until you specify it, it can be anything you want, all right? So this is the whole idea behind having a generic function in TypeScript or in Go or whatever. It's exactly the same idea. The syntax for this language is different, of course, but the idea is the same. Once you understand the principle, the logic, implementation is just language grammar, and it's easier for you to understand how this language grammar works. So now in Go, the way that we're going to go with this is going to be a mixture of manual and using built-in methods. So what we want to do is we want to create an array that's going to be called unique array. I'm just going to say it as array, and we're going to use short variable declarations to create this. Now, we're going to use the make method to create a new array. Now, what is the type of this array? I don't know. It is of type T. So if the first T next to comparable is integer, the second T, the third one, and the fourth one, all four of them are going to be integer, all right? So that's T. And here, what I want to do first is I want to create a map. And we're going to give this map keys, and we're going to give this map values as well. So let's go ahead and let's create it. Now, the keys of the map, they're going to be the items from our array. Now, since this is a map, the keys of the map cannot be redundant. They cannot be duplicates. But because this is a map, it doesn't consider order. So the order of the elements might change as we pass them to this map. But we talked about the keys of the map are going to be the items of the array. But what about the values for those keys? They're going to be of Boolean type. Why? Because we need to specify if we have seen something, if we have actually added a unique element, or this element is a duplicate one. We need to specify that using this bool. So what we need to do next is we need to create a slice in order to make sure that whatever keys that we get from this map, they can be ordered. Because once we remove the duplicates, as I said in previous languages, we want to keep the order. So it's still 1, 2, 3, 4. Just get rid of the duplicates. So here is where I'm going to create a result array using short variable declaration. And I'm going to say, okay, this is going to be an array, again, of type T. See? T. So now there are 6 T's. Once I know the first T, the rest of them are going to be the same thing. But the length of this is going to start at 0. Now, the initial length of this array is going to be 0. But we can add to this, and this array or this slice in Go, as we call it in Go, it is going to grow automatically as we add elements. So how do we add elements? Well, let's iterate over our input array. That's how we add elements. So whenever we iterate over an array, we get 2 things. We get an index in which, in this scenario, we don't care about that. That's why I'm going to pass in the blank identifier underscore. And then we get the actual element. So I could call it element, or I could call it item. Just so I go along with the Python solution, I'm just going to call it element. Now let's grab our range, which is going to iterate over our array. And now that we are inside of this for loop, what do we want to do? Well, we have successfully we are in the process of iterating over our input array. But then we need to take a look at our unique array, which is actually a map, in order to see if this item has already been added as a key to that specific map. So how do we do that? Well, we need to have some sort of a conditional. So in here, I'm going to say if unique array in this specific iteration count for this specific element has not been added to this array. So I'm going to flip this. So if I say unique array element, that means it has been added. But if I flip this, that means it has not been added. This is something new that we want to add. So if this has not been added, we want to add it to this map. So let's go ahead and let's add it. I'm going to grab, well, I shouldn't call this unique array. You know what? Instead of this unique array, I'm just going to call it scene. That makes more sense. Scene. So if we have seen this item inside of our scene map, because you need to keep in mind that this is not an array, this is actually a map. So if it has been seen, let's change the value of the Boolean. So I'm going to pass in the item. Again, item, I'm going to call it element. And so element is going to be the key for that specific member of that map, which is a dictionary or an object. But what is the value for that key? As we talked about, the value has a type of Boolean. So what is the value? Well, since we added that, we're going to say Boolean is true. Now, let's take a look at our very first array, or basically the second one, not the first one, the string one here. So if we take a look at A, and A has not been added to the scene map, so we grab A and we add it as a member to the scene map. But since this is a key, it requires a value as well, the value for which is true. Now, since it is true, see, it is true, we are not going to enter this if statement in the next iteration when we talk about A, because A has already been added to the scene map. All right? That's why we have said that the values that we use for our keys for the dictionary, they're going to be of type Boolean, because it's exactly like is duplicate that we used inside of TypeScript, but it's in a different way. Again, as I said, it's language specific, so we go this way. All right, so now that we have added that to the scene, how do we add it to the result? Because we need to keep the order. Well, let's go ahead and let's grab our result array. And how do we add it? Well, we are going to say append result array and then the element itself. And that's it. Let's return the result array as well. And that's basically it. So in the first iteration, let's go over a few iterations. In the first one, we get A. We don't care about the index. Is A already inside of the scene map? No, it's not. A is not inside of the scene object or map or dictionary. I hope these names are not confusing. The name is changed based on the language. So if A is not inside of the object, let's add it to the object by this line. But since it's an object, it requires a key and a value. What is the key? The key is the actual item A. What is the value? It's true. Okay, cool. Then I'm going to grab that A and I'm going to add it to my result array as well. Okay, cool. Let's go to the next iteration. Next iteration, it is A again. So this is a duplicate and I should not add it to my scene and not to my result. So if I take a look at this, is A already been added to the scene? Yes, it has been added. So this is false. I mean, this is already false, so it's a false, right? So we don't go inside of the if statement and we don't run this, we go to our next iteration. So this line basically says if some element has not already been added. If the element has been added, we do not go inside of the if statement. If the element has already been added, if it is a duplicate, we do not go inside of the if statement. We only go if this is not seen. This is a unique element. All right, so this is how it works. And I've already created our main function. Let me just put it there. And let's just import this one, save this, cd this, clear, go run the tab, enter. Let's wait a few seconds. And there we go. So we got our original number, 1, 2, 2, 3, 3, 4. You can see we keep the order, right? And then we have A, B, C, A, C, B. We get A, B, C. Now, we could also take a look at our map right here. So let me just, before the result right here, I'm going to say fmt.print print line, and I'm going to pass in this is going to be the scene map, aka object, and let's just pass that in there. So that's going to be scene. There we go. Let's go above and let's run this again. Okay, let me just move it a little bit up. Let me just clear this and run it again. And there we go. So you can see this is what we get. Let's take a look at it. So here we have 1, which is true, 2 is true, 3 is true, 4 is true. And the same goes for A, B, and C. We get true, true, and true. Now, in this specific scenario, this has kept the order, but you might have some sort of a map or object which does not actually keep the order. That's why we created a new array in order to do that. Right? Cool. So this is one way. You could actually select this, get all the keys from it, and then sort all the keys, and that's going to be the order for you. But sorting does not actually guarantee the specific order. What if the numbers are like 4, 3, 2, 1, 10, 15, 9, 5? So you can see it's all over the place in that scenario. So if you sort it, you're going to basically lose the original order. All right. So this is just one way to go about this. Feel free to do this in any way that you want, as long as you get the same result. And for the Rust solution, let me first open up the file. Whoops, again, I pasted that instead of collapsing it. We want to keep everything simple. we have already talked about Rust solutions for arrays that have several different types of items inside of them, and how to create a function that can handle that functionality. So for this specific challenge, we want to keep everything simple. We are going to have one function that is going to remove duplicates from a numbers array, and then we're going to have a function that's going to remove duplicates from a strings array, because I want to go in a different way. You can very well create a macro, create implementations, and create just one function that is able to handle all types of arrays. And you can handle edge cases like an empty array as well. So if you want to do that, you can just go ahead and watch the previous challenges in the series, like namely challenge 11 and 12 and those challenges. So for now, let's just go ahead and keep everything simple. We have a function that we are going to call remove duplicates underscore numbers. We're going to keep it very, very simple. This is going to accept an array, and this is going to be of type number. So we're going to just keep it to integer, not floats. So the array type, the type of the items within the array, they're going to be i32 or integer 32, but we want to pass a reference to them because we don't want to take ownership. Now, what does the function produce? Function accepts a vector and it produces a vector as well. So vector, but what is the type of the elements within that vector? It's the same type as the input array. So i32. All right, so first off, I want to create a hash set, and I want to make sure I can use the hash set in order to take a look at any element that is either unique or duplicate. And the reason that I'm using hash sets is because hash set only stores unique values. It's perfect for duplicate detection. So I'm going to say let mut, because this is going to be mutable. It's going to change. It's going to add elements. It's going to have the ability to add elements to it. We're going to call it the same thing that we called it in Go because it's almost the same thing. We're going to say hash set, just create a new one. We need to import this hash set as well. So I'm going to say use from the standard library collections. We are going to grab hash set. Just make sure you need to pass in double colons there. Let me terminate this line. Now, this is all the elements that we have seen, but they are unique elements. But then we need to return a vector from this function. So we're going to say mut. This is going to be our result array, right? And this is going to be a new vector, and the type of which is going to be implied or inferred. All right, now let's iterate over our input vector or input slice. Now, since the items are references, we need to dereference the items of the array in order to get the actual value. So how do we dereference? Well, we pass in the ampersand sign, and you could call this num or element. Since we are inside of a function that only handles numbers, we could just call this num, right? In array, but then we need to convert this array into an iterable so we can iterate over it. All right, so how do we go about this? Well, we have already done this a couple of times. We did it in TypeScript inside of this for loop, the logic, and we did it in Go. So we want to see in this specific implementation of the solution to this challenge, we want to add an element to our scene set if that element can be inserted in there, if the element is unique. Because if the element is duplicate, hash set is not going to allow it to be added in there. Hash set only accepts unique elements. So I'm going to say if scene dot insert that specific number returns true, if I can insert this number into this scene set, that means this number is a unique element. It's not a duplicate. If this line, this part, this expression returns true, then it means num is a unique element. What do I want to do with that unique element? Well, I want to grab my result array and push it to that result array. That's what I want to do. And that's basically it. We're done. And then we return the result array. And then we go to the next iteration, next iteration. So for our strings array, the first item is A. We're going to add it to our scene. The second item is A as well, but that's a duplicate. So this if statement, this condition for the if statement is not going to hold true. Therefore, we're not going to push it to our result array. Very cool, right? So we use these kind of like hash sets or maps, the map that we used in Go just for our function, for our condition, for our if statement condition, all right? But the actual result is inside of this array. Now, this was the function to remove duplicates from an array of strings. We could go the same way for a function to remove duplicates for an array of sorry, I said it in reverse. So this is to remove duplicates for an array of numbers, and then we could go almost the same way to remove duplicates from an array of strings. So how do you go about this? We need to change the types. All right, so the type of this is going to be a string. So let me pass a string. But what does this function produce? Well, it is going to produce owned strings. Well, it's up to you if you want to produce string slices or owned strings. I'm just going to have my function produce owned strings. That's why it's capital string. We still need to have our scene. We still need to have our result array. And now, instead of this num, we want to dereferences, and we could just call it S, short for string. I don't want to pass an str because that's actually a type inside of Rust. So we have our array, we convert it into an iterator. We say, okay, if scene.insert S returns true, but this S is a reference to a value. We need to convert it to a owned string. How do you convert it? We just call to underscore string, and that's it. So if this condition holds true, that means this specific item, this specific string is a unique one. Well, then we push it to our result array as well in the same scenario, in the same manner. And that's it. And then we return that. So that's it. Let's go ahead and let me copy paste this function. So what do we have here? We have our numbers 1, 2, 2, 3, 3, 4 input, as well as the output right there. And then we have this line that says testing with strings, our strings. Up until here, we have our input, and then here we have our output. Now let's take a look at how many errors we need to solve. Clear Rust C E tab, enter. All right, let me go to the top. Let's see what's going on. Doesn't have a size known at compile time. It says help trait size is not implemented for string slice with and array elements must have sized type. We go down, error cannot be called due to unset of a trait bounds. So one of this, we could solve this issue by just specifying that this is a reference. So we have already stated that this vector is a reference. But we could also say that the items within this are also references. They're not actual values, they're references. Now, let me just run this again. We still have, okay, now here we just have a couple of suggestions. You can see they're yellow because I've used a basically notation that is not okay in Rust. So it says this result array, it should be result underscore array. So wherever I've used this, I should rectify it. Let's save that. And there we go. Let's go to terminal, clear this and run it again. There we go, it compiled. We're gonna run this, remove duplicates. Okay. Why don't we have anything? So print line input, everything seems to be okay. Strings output, remove duplicates, pass in, run this again. Oh, I can see what the problem is. So let me just clear the terminal. So when I say E tab, now it is selecting this exe file. That's the file that I want to run. But if I move up with the up arrow, you can see here I'm trying to run this Rust file. It doesn't work like that. You need to run the exe file, this one. And there we go. We get our result. So we have this 1, 2, 2, 3, 3, 4, 1, 2, 3, 4, and then we have our array of strings where we have only ABC. And I believe this is it for the Rust solution. So we did solve this, remove duplicates for JavaScript, TypeScript, Python, Go, and Rust. And I believe with this, our challenge has come to an end. So see you in the next one.